Alright, in today's video we're going to talk about how to lay out HVAC equipment. So we're going to talk first about the indoor units, which is commonly designated as AHU, which stands for Air Handling Unit, and also the outdoor units, which are the condensing units. So this is what a condensing unit typically looks like. They could come in different sizes, generally smaller the less tonnage, and the large ones such as this they have a higher tonnage capacity, and these units, which are even larger than these, generally have a higher tonnage than these smaller units. So we're gonna talk about those layouts, and then we're gonna talk about laying out the duct system, just generally, not really the sizing, but just generally how to lay out the duct systems, as well as the supply outlet and return openings. Some examples are this here. This is a linear slot diffuser, or it can actually act as a return. So some of these, and if you look here, it can actually serve as both a supply and a return, where a portion of this linear can be a supply and other portions of this same linear can be a return, depending on how this is ducted behind the wall, or it could be behind a ceiling as well. Now this is also, and if you look here, this is an example of some ductwork, as well as the supply diffusers here, and in this case they're the square diffusers, which are exposed in this case. Okay, so for this example, we have a residential building with 3 units. So it's a 3-family unit. It's going to have these many floors, so 3 floors plus a cellar and a basement, so a total of 5 floors here. The cellar will be a common area, meaning that all occupants of this building has access to it. Generally can be used for storage or to check on utility meters such as gas and the water service meters. And one unit will occupy 2 floors, so it'll be a duplex occupying the basement and first floor. One unit will occupy the second floor, and one unit will occupy the 3rd floor. The cellar in this case will receive no cooling, because the owner wishes to save on cost, and the cellar is not occupied by people, so they don't want to install a cooling system for the cellar. But we still need to provide some type of heating for the cellar in order to prevent pipes from freezing and bursting. So that will be the condition for the cellar. Now for the basements, the ceiling is low, so the HVAC unit will be installed in the cellar and ducted to the basement floor. One unit to serve entire floor. On the first floor, there's going to be a ceiling concealed ducted unit. Second floor, similar type of case, ceiling concealed ducted unit. The 3rd floor will be a floor mounted ducted unit in order to keep the ceilings high throughout that floor. And again, it'll just be one unit serving that floor. And the condensing units will all be mounted on the roof. So in this case, since we have 3 separate units, there is going to be 3 separate electric meters, where each tenant will have to pay their own electric consumption. So each tenant will have its own electric meter, which means that the HVAC system for each tenant will have to be on its own meter as well. So every tenant will have to get its own condensing unit, all connected to the indoor units for that tenant, because these condensing units can be connected to multiple indoor units. And if the indoor unit for another tenant is connected to the condensing unit of a different tenant, that tenant may be paying for the usage for some other tenant. So you want to keep all the systems independent for each tenant. So in this case, we're going to be selecting the Mitsubishi unit because the client for this property, in our example, wants Mitsubishi units. It's their preference. There's many different types. It could be a Mitsubishi, it could be a Daikin, it could be a LG unit, and many other manufacturers make similar type of HVAC equipment. But in this case, we're going to go with the Mitsubishi units, which are very common. And the model numbers will be these here. So for the basement, it's going to be this model, first floor, second, third floor. The models are all listed here. Since the first and second floor were both in this example going to be the ceiling concealed ducted units, they're going to be the same model number, as you can tell right here. And the third floor unit will be the floor standing unit, which is the PVA right here. Now the design considerations will be: unit needs to be laid out to maintain clearance requirements as indicated in the manufacturer's specifications. The clearance are needed to pull out and replace filters, as well as gain access for general maintenance and repair. So it's very important to make sure you figure out what the clearance requirements are by looking at the equipment specification sheets that usually can be found online, or you can ask the manufacturer's rep to send you some specifications detailing what the clearance requirements are. And that's one thing to consider. Another thing is, if the unit is located in the ceiling, access panels will need to be installed in sheetrock ceilings. So the access panels should be located in areas where aesthetics may not be a concern, such as in closets or bathrooms. If the ceiling is drop ceiling type, typical in office spaces, the tiles can be removed and serve as access panels. And this is generally what the office drop ceilings look like. These are removable access panels. Typically they come in sizes of 2 by 2, so 2 feet by 2 feet, or it could be different size, such as 4 feet by 2 feet. So those are very common sizes. And if you have a unit above an office space, the access panels can be any of these ceiling tiles, which can be removed. But in a residential building where you don't have these removable access panels and you just have sheetrock, you will need a different type of access panel. And in the residential case, it is these type of access panels that will be needed if it's a sheetrock ceiling such as this. And as you can tell, it's noticeable, so generally the architects and the owners prefer to have these in place that is not typically visible, such as in closets, or maybe where they don't really care how it looks, such as bathroom. Now the units should also be located in areas where noise concerns may not be such an issue, such as in bathrooms and closets. And generally you want to keep it out of places such as bedrooms, where noise can also be an issue, or in like an office space in a residential building, or in a place where, let's say, a living room or something like that, where noise can be an issue. So you want to consider that as well. Also, you want to put the units, the air handling units, in a space where you can easily make a transition in the ductwork. So you need a little bit of space to make that transition. And for example, in this case, this is the ceiling concealed unit. So as you can tell, it needs some sort of clearance in front for the ductwork and the transitions to the ductwork. So this is the concealed ceiling unit. Well, in this case, it's exposed, but these can also be mounted concealed above a ceiling. And if you look closely, there's two lines here, which are the refrigerant supply and return. and you can tell there's hangers that are supporting this unit, and the supply is on one side and the return to this unit is actually on the back side of the unit, which you can't really see in this picture. For the floor standing unit, it looks like this, and the supply is right on top of the unit, and the return is on the bottom or the opposite side of the supply. So the return is going to be on this side. So what they did in this case was they mounted a return duct here. They put an opening where the return air would go in here and then right up into the unit, and the fan will be here blowing the air right through all the coils to the supply duct, which will be on top. So in this case, this model number is different from the one that we will be specifying, which was the floor standing units from Mitsubishi, the PVA and the SVZ, which those Mitsubishi units perform heating through a heat pump system. So it's all from the refrigerant. This specific unit is a little bit different in that the heat is being provided by gas, and this is the gas piping. It's the black pipe here, and here you can kind of see the gas pipe valve, and it's connected right here into this unit. And with these gas furnaces, you're going to also see a vent for the combustion air. After the gas is fired, the byproducts has to go through a combustion vent. So this is the combustion vent for in this case, and you also have another vent for the exhaust vent. So typical in a gas furnace, you'll see combustion vents as well as an exhaust vent. So the combustion vent is for the air that will get mixed in with the gas before it ignites, and then once the combustion happens, the byproduct of that combustion will go through this exhaust vent. Sometimes for the combustion air, it doesn't actually get piped to the unit. Sometimes the outside air will just open up into the room of the HVAC equipment, and it will not be directly connected to the HVAC equipment, as in this case with this pipe here. You can also see there's PVC piping, which is this white pipe here. PVC is a plastic pipe, and this is for the drainage. Okay, any type of drainage, as you can see, is here too, will be done through this PVC piping. And in these two pictures on the right are two examples of how ductwork is routed above a ceiling. And these two pictures are shown without the ceiling attached, and if the ceiling was attached, it would actually attach to the underside of this joist, and all this ductwork would be above the ceiling that would be installed. And if you look back here, these are actually light fixtures. So sometimes when you route ductwork, you have to sometimes avoid these light fixtures because they actually go up above the ceiling by sometimes 4 to 6 inches. So you have to account for that when routing your ductwork. On the bottom here is rectangular ducts. They're sheet metal, and in this case you could see again it's routed above a ceiling, which would then be installed pretty much to the underside of this wood framing here. Going back to the slot diffuser, what it looks like behind the slot diffuser looks like this. So this would be the part that is exposed, right? It could be exposed either on the ceiling or on the wall, and this is the plenum box. So this is a detail of what it could look like. And this is a supply duct here in this case, and it's connected with a small piece of flexible ductwork which connects the supply duct to the plenum box to the linear slot. In this case it's a little different. This looks more like a grill if you zoom in, but this could also represent a linear slot which could be mounted on a wall, or if this was reconfigured slightly and the opening was down here, that would be for something like this, and this would be a ceiling mounted linear. So when installing the condensing unit, you also have to follow some clearances for the unit to operate correctly. And each manufacturer will have their own recommended clearances for the condensing unit, and it would look something like this diagram here. So there's different clearances required for the different configurations, and if you look at one configuration, which is there is nothing obstructing it all around except for this back wall, for a single condensing unit you need 6 inches about of clearance. These are all in units of inches, and the reason for that is so that the air can actually go to the backside of the condensing unit and blow out through the front, transferring the heat from the refrigerant either out of the refrigerant or transferring heat into the refrigerant, depending on what type of operation you're in, whether you're in cooling or heating. And also there's a lot of different configurations here, as you can see. In this case there's obstructions on basically 4 sides, 1, 2, 3, and the back side. There's nothing in the front, and in this case you need clearances on all those dimensions, right, from the sides to the top and the back. You also could have different configurations where they are kind of stacked up on top of each other, or they are back to back. So in this case the air would go in between the 2 units and then blow in opposite directions, one going this way, and for this unit it would blow this way. And you would need clearance in this situation of 24 inches. 24 inches here. Okay, now that we went through the basic idea of what we need to do in this example, we're going to start laying out the units in AutoCAD. Before we do that, I want to just give a reminder as to what needs to be done. So we are installing these units. One in the basement, it's the SVZ model. 2 ceiling concealed units on the 1st and 2nd floor. And on the 3rd floor it's going to be the PVA model, which is going to be a floor standing unit. So if we start with the basement, which is this floor here, we're going to, in this example, install it in the cellar, the unit. And the reason again is because the ceiling in the basement is too low. So if we add a unit somewhere in here in the ceiling, we don't have the ceiling space for it, because if we put it in the ceiling, we're going to have to drop the ceiling so it fits, and that will lower the actual ceiling height of this floor. So we're going to install the unit in the cellar, and we're going to put it in this mechanical room that was provided by the architect. And as you can tell in this floor here, the cellar, you have this is a hatch to basically the ground level, which is right here, and you also have another hatch here which is accessed from the cellar through this hatch opening here. You have a restroom. This is a water closet or a toilet and a sink, and these represent light fixtures, and this P1 just identifies what light fixture it is, and they would typically have some sort of schedule that will give you the model number based on the ID tags, such as in this case the ID tag is P1. And you have some storage rooms here, 1, 2, and this area here represents the water main as well as the meters. So some of these might represent the water meters and electric meters. This is a stair to the basement floor. And here is the laundry room. So these probably represent either washers or dryers in some sort of combination here. So we're going to lay out the first unit, which is the SVZ model. So let's go back here. So the basement is going to be the SVZ model. So going back into AutoCAD, we have a couple of details drawn out in blocks here. So the Mitsubishi units are all lined up in this area here. And the SVZ will be these two things here. And the same unit can be rotated so that it could be in a floor standing configuration or a horizontal configuration, such as here. And this yellow dashed line represents the clearance requirements of the unit. And if you rotate it to a horizontal configuration, this clearance right here is just this clearance here as well. So if you look at a spec sheet on this, this is the SVZ model, and here is in the floor standing configuration where the air goes into the bottom of the unit and out to the top. So this would be the supply and this would be the return. If you were to have a horizontal configuration, this unit would actually just rotate 90 degrees, either this way or this way. And if you look at a more detailed picture of it, it looks very similar to the PVA, so I'll just show you the PVA, although we are right now looking at the SVZ, but the PVA is very similar to that. So I'll just show you this picture here. So if you look here, this would be the floor standing configuration, and if this was now rotated this way, that would be the horizontal configuration. Or I also believe that you can rotate it this way too. Either way should be fine. And there's a couple of drain ports here as well, and here. And this is for the condensate piping. So this unit gives the installer a couple of options of holes that they can use to pipe the condensate drain, depending on what is more better for the installer. So this, looking this way, this is the view that you see. It's just an opening for the return. And if you look down this way, this is the view you would see. And again, this is the opening for the supply air to come out. And looking this way, this is the view that you would see. And looking this way, you would see this view here. And if you look here, this is where the coil is. So it'll probably just be something like this inside. This is the blower section. So the fan would be positioned something like this. So for this case, we're going to mount it in the horizontal configuration, just so that we have a little bit more floor space that we can use for storage. So I'm going to move this into the mechanical room here. And the architect also gave an indication that this is where they want the new HVAC units here. So we don't have to put it exactly in this spot, but this is just the architect's idea of where they wanted the HVAC equipment. So we will put it in this room, and we're going to rotate it this way and place it somewhere here, making sure that we also have the clearance requirements for maintenance purposes. Now we need to think about how we're going to duct this horizontal unit to the basement floor. And again, this floor we are trying to maximize the ceiling, and typically for a residential building, the joists are running across the shorter dimension and not in this direction, which is the longer dimension. So if this is the joist, it's going to run something like this. So if you look here, the joists are actually these things here. These are the joists here. And the ceiling is going to be mounted right to the underside of this joist. So if the joists are running in this direction and the ceiling needs to be as high as possible in this location, we cannot run the ductwork this way, perpendicular to the joist. Otherwise, the ceiling has to come down in order for the ducts to run underneath the joist. So we want to avoid that, and if possible, the ducts would actually run in parallel to the joist, and it will be routed basically in between the joists. So in this example, what the architect decided to do was to give us a small drop ceiling portion where we can run ductworks perpendicular to the joist, and that drop ceiling is represented by this dotted line here. So in this case, the drop ceiling would be this portion here. And also they gave a small drop ceiling right after this door opening of this amount right here. So we're going to utilize this in order to run some of the ductwork. And this is the shaft that the architect gave us where we can route some ductwork up to this floor. So what I would do is, in this case, we move it. I type in M to go to these layers that start with M, and here the M stands for mechanical, so I'm going to select the mechanical supply duct layer here, and we're going to draw a box here for the supply and another box here for the supply, and make some lines this way. And these actually represent the return ducts. So I'm just gonna do this, do this. These represent the return, so we'll have to change this to the correct layer, which is the M return duct layer. So I'm going to copy this using this corner as a reference point to see where it lines up in the cellar, and it lines up right here. So we're going to start routing the ductwork from the supply outlet here. Actually, to figure out where the supply outlet is, you can tell here these are the refrigerant piping connections here. This is the refrigerant piping, and the supply is on that side. So you know that the air is actually moving this way. So the supply would be on this side, and it would connect to these units here. So this will be one unit, and this will be another connection here. And what I do is do a chamfer command, and we basically chamfer the ducts to show that it is a 45-degree angle connection rather than a straight 90-degree elbow. So whenever you make a turn, this is the graphics that we use. And the return will actually just be open into the mechanical room, and the air would actually return back into the mechanical room and then return back into the return of the unit, which is back here. So in this case, the room is acting as the return air plenum.